In this presentation, we're going to look at the exponential distribution, and it's going to be pretty much a quick worked example. So down below, I have shortened versions of the what you would see in the formula sheet. Okay, so it's essentially the complement of the cumulative distribution function, and then the actual cumulative distribution function there. So it's just a sort of quick formula with respect to that. So probability of x greater than or equal to k, where k is some observed value and lambda is the rate parameter. Okay. Something to remember is that lambda is the inverse of the mean. So lambda equals 1 over mu, i.e. 1 over the mean. Okay. And the mean values are typically given in the question. Okay. Now, the average lifespan of a laptop is 5 years. So that's our mu. Mu is equal to 5 years. Okay. You may assume that the lifespan of laptops follow an exponential distribution. If you're not told that, it makes life very hard. So typically you're told it. Okay. Useful calculations are provided. So this is just actually a little bit of help to sort of speed things up with regard to calculator work. So just some values there. They're not typically given in the question, but just for this particular video. I had them ready, so I just left them in. Okay, so first thing you should do actually is, I'll just actually write it down here. X is lifetimes of laptops. Just a quick sort of statement of about what X is, okay? And also a specification in terms of the exponential distribution, and you should say something like this: mu is equal to 1 over 5. Okay, so this should appear near the start of your question. In fact, this should also appear together with it. Okay, before you even start answering questions, just actually state what you're doing. It just demonstrates your comprehension of the question. Okay, so the probability in the first part here, the probability of x greater than equal to 6. Okay, just as a quick remark, at least 6 years. Okay, just as a quick remark actually, before I go any further, you notice that I have greater than or equal to here and less than or equal to here. That's actually not strictly true. The case is that the equality operator, the probability of x equal to some particular value, precise value, is considered to be negligible. Okay, for continuous random variables. That's a continuous random variables only. Okay, so correctly, this is not, these are not strictly speaking the complements of each other, but the difference is considered to be negligible. Okay, that's just an important little thing here. Okay, so back to the question: probability of x greater than or equal to 6. So I'm going to use this formula here. Okay, this one here, and that is e to the minus k times lambda. Okay, so whoops, so that is the exponential of minus 6 times 1 over 5, and there we have it there. It works out to be approximately 30%, 0.3011. Okay, that's the first question there. The second question is, what is the probability of that the laptop will not exceed 4 years? So that is what we're asked for essentially. And how to find that? That is 1 minus e to the 4 over 5. Okay, that's just using the formula that I mentioned previously. Just working that out, that's a little bit of calculator work. So that should be 0.5507. Okay. And what is the probability that the laptop will be between 5 years and 6 years? Okay. So this is a little bit tricky. Okay. Now, in other videos, what I would do is, it's not tricky, but essentially the way I'm going to approach this question in this particular instance is sort of say, we're going to find the probability of laptops lasting greater than 5 years, okay, but we're going to subtract from that the probability of them lasting greater than 6 years, okay. So that is the approach we're going to take here. So 5 or more minus 6 or more, that gives us the probability of being between 5 and 6. And actually, something I should really do before I begin this is actually just talk about the mathematical specification of the question that we're being asked. The probability of 5 less than or equal to 6 less than or equal to x less than or equal to 6. Okay, so the answer in this case is 0.3678, just working to 4 decimal places like I've done previously, minus 0.3, sorry, my pen is slipping here, 3011. Little bit of calculator work, that's around 6%, 0.667. Okay, so that's the answer to the third one there. So that's based on the answer above there in part A as well. I'm using part A to as part of my answer to part C, and you can usually sort of state that or sort of assume that you get to use previous parts of questions. Okay, that's good. We leave that there.